All right, so we are going to be starting taking our first set of notes in the unit of conservation of mass. And there will be several parts to these notes over the next few weeks. Remember that the main standard that we're trying to work to understand is the properties of matter are determined by the arrangement of atoms. So to start off, we're mainly focusing on the I can statement of drawing a diagram of an atom and its subatomic particles. We also are going to be working on the I can statement of explaining where and how elements are grouped on the periodic table. Your first quiz, which will be sometime towards the end of next week, will cover both of these I can statements. Here's one example of the periodic table. I kind of like this one because it has pictures. And these pictures show, it gives clues about the properties of each element and what we use them for. So the periodic table is an arrangement of all the elements by their properties. And it provides information about each element's atoms. Within a couple days, you will be able to draw a diagram of any of the elements on the first probably 2 to 3 rows of the periodic table. So what is an element? An element is a simple substance that can't be broken down into any other substances. Meaning, let's take oxygen for example. If you have an atom of oxygen, oxygen is a substance. It's a pure substance, and it cannot be broken down into any other substance. And each element has its own space in the periodic table, which is represented by these squares or rectangles. And currently, I think there's about 118 elements that have been placed on the periodic table. All matter is made up of at least one element, but most matter is made up of more than one element. Now, in talking about this, the word matter has come up. And so we really need to kind of address what is matter. So, matter is and what I really mean by this is anything that has volume, which means it takes up space, and mass, which means that it has a certain amount of matter or particles that make it up. Hydrogen, oxygen, sodium, and chloride are all examples of single elements that appear on the periodic table. So those cannot be broken down into any further substances. Water is a combination of hydrogen and oxygen atoms. And so pure water, which is just comprised of hydrogen and oxygen atoms, can be broken down into oxygen and hydrogen as two different substances. Salt is also a pure substance, and it is combined from sodium and chloride. An atom is the smallest building block or whole piece of matter that can't be broken down by ordinary chemical means. So an element is made up of atoms. So you could have one atom of an element or several atoms of a specific element. Take gold, for example. You can have one atom of element that is invisible to the human eye, or you can have a clump of gold atoms and make a profit off that. Each atom of a specific element has a certain atomic structure. So what we're going to learn how to do is to draw the atomic structure of the elements that are listed um, in the upper part of the periodic table. We're also going to be learning how to identify what element is shown to you in atomic structure form. So I should be able to give you a diagram and say what element is this representing. Atoms, if you look at this, I like this diagram a lot. Atoms have a center part to it called the nucleus, and they also have a larger outer area that is called the electron cloud. And the interior nucleus has two types of particles in it, and the electron cloud has one particle moving about it, which we'll talk more in depth of. So as you know now, the nucleus is the center part of an atom. It's pretty small when considering how big of a space the entire atom takes up. It contains both protons, which you'll see over here are the positively charged particles. It also has neutrons, which are neutrally charged or a zero charge. Neutrons and protons have two things in common. Not only do they have the same size and the same mass, but they also have, they're located in the same area of the atom. Another subparticle of atoms is the electron. It is the negatively charged particle in an atom. And that is the particle that revolves around the nucleus of an atom. Electrons, even though they have much more space to move around, are actually much smaller and have less mass than protons and neutrons. So the electron cloud is mostly space versus mass or matter. Now, the electron cloud, let's talk a little bit deeper about that. It actually is broken up into energy levels. And we aren't going to be studying all of the energy levels within the electron cloud. I want you mainly to focus on the first energy level and the second energy level. The first energy level is closest to the nucleus, and it can hold only two electrons. It can hold less than 2 electrons, meaning 1, or it can hold 2. And if it has 2, then that is considered to be a full energy level. So if an atom has any more electrons than 2, then that is where they end up going to the second energy level out further away from the nucleus. Atoms are considered to be happy if their outer energy level is full. So, in order to become full, atoms release, share, or take electrons. So that's kind of their relationship with other atoms. And we'll get into that further later. So, order of elements on the periodic table. If you look on the periodic table that is actually on your student notes, you should be able to locate helium. Notice that there is a 2 as one of the numbers with helium. The 2 represents the atomic number. And although it has other meanings, it kind of helps you find its location, and this is how it was placed on the periodic table. Hydrogen, which is on the other side of the periodic table, has an atomic number of 1. Helium has 2. If you look below hydrogen on your periodic table, you'll know that it has 3. And that it kind of goes across where there's let's see, what is next? Beryllium. Beryllium is 4, boron is 5, carbon is 6, and I'm just reading straight across the periodic table. So, it kind of reads like a book. The periodic table does. It goes from left to right, and when you finish that line, you go to the next line, and so forth, all the way across the periodic table to the bottom of it. Each square or rectangle representing a different element has several different parts. As you can see up here, there's the atomic number, there's the chemical, and here it's called an atomic symbol, actually it's usually called the chemical symbol. Then there's the atomic mass, which we'll get into. I'm just kind of making a disaster mess on this, but you probably are getting the picture. Sometimes it will list the actual long name of the element, but this one doesn't. All right, so now we're actually getting into drawing diagrams. Here is a helium atom diagram. This is a type of simple diagram that I'm going to expect you to be able to draw in a few days. It shows the 3 subatomic particles, and it also shows the energy levels. Now notice that it looks like there's 2 energy levels here, but this one is just the outside of the nucleus that's holding in those protons and electrons. I'm sorry, protons and neutrons. So let's start with this. The atomic number. And this is a number listed on the periodic table for each element, like we stated in the last slide. It states the number of protons, which is something new. That's a new piece of information for you. So, how we said that hydrogen has the number 1 listed with it, it tells you that it has 1 proton. If an atom doesn't have 1 proton, then it is not hydrogen. Helium atoms has the atomic number of 2, and that means that it has 2 protons, and so forth down the periodic table. No 2 elements have the same number of protons, therefore, no 2 elements have the same atomic number. And since most atoms have a balanced or 0 charge, here comes the math word for you, they have the same number of electrons as protons. So, again, this isn't every atom, but most atoms are naturally balanced with a 0 charge. So if it has 1 proton, being hydrogen, then hydrogen is also going to have 1 electron. Helium, if it is a balanced helium atom, it's going to have 2 protons because the atomic number is 2, which means in order to be balanced, it would also have 2 electrons. Atomic mass and mass number. The definition of atomic mass is an atom's average mass. Because atoms can have different number of neutrons or electrons than what the balanced atom might have, they do kind of find the average mass of different isotopes and ions, and that's how they come up with the atomic mass. So it always has a decimal point in it. You'll notice the one for helium was 4.00. Not all of them are that well-rounded. Remember that an atom of a certain element has to have a certain number of protons. So helium is always going to have 2 protons. It may or may not have the same number of neutrons and electrons in each of its atoms. Mass number. The mass number is the rounded atomic mass. So for helium, it's pretty easy in this diagram. The rounded atomic mass would be 4. but some of them you actually have to round to the nearest whole number.